make sure when the blood flows, we need to make sure it flows in one direction only. That means if it is supposed to leave the heart, leave. Do not come back. When it returns and goes to the lungs, leave. Don't come back. So the structure, having it be continuous between the heart, the valves, and the vessels, helps us to ensure one-way blood flow. When it begins to back up, which does happen, for example, when the valves are insufficient, valvular insufficiency is what you'll hear it termed, okay? That creates a lot of problems throughout the entire body. So the goal, keep the blood flowing in one direction. Our myocardium, let that think of muscle. Because up to this point, I haven't mentioned anything about cardiac muscle. I've mentioned the pericardium, I've mentioned the visceral portion, the parietal portion, and epicardium, endocardium. It is in the middle that I find myocardium. This is the area of the actual muscle of the heart. This is the area for cardiac muscle. This middle portion that runs on each side of the heart. This is my cardiac muscle. The bundles, because remember, that's how we have muscle do, actually spiral around the heart. When the heart beats, okay, it literally, when you get to look at a heart, it actually does a twist right here when you look at it. And when the heart beats, what happens is it goes it actually starts right here at the apex. And when it twists, that gets to push the blood out to the great vessels. And that is what cardiac muscle can help to do. When you look at the chambers that are present, you're going to see myocardium between the lower chambers. Atria? No, not really. It is the lower chambers, the ventricles, that have to have these cardiac muscle cells because they are the working portion of the heartbeat. They have to be able to twist and release because you gotta push the blood out. That's going to get very important. We also find that we have a fibrous skeleton. It is our collagen and elastic fibers. They are concentrated around the valves. Okay, the structure gets really, really important. They give structural support to the heart as a whole and definitely valves. and especially to my great vessels. They help to anchor my cardiomyocytes, my cardiac muscle. Now, let me think here for a second for this right here. The skeleton is an electrical insulation. Electrical insulation. Does that mean it passes the electrical impulse? If you think of insulation on wires in a wire, see Brian shaking his head? No, he is correct. They do not pass the electrical impulse. It is going to be up to each individual cardiac cell. So the skeleton is simply insulating this. Now, let's put this in perspective. That means that an electrical impulse of the heart is what is going to make it go, okay? How many times per minute does that happen?
40 to 70.
If you're at 40, you're in trouble.
60.
You should have roughly 60 to 75. Going up, that's okay. That depends on your physical condition. The better your physical condition, the better it can withstand a higher rate. And then at rest, it can be lower. Because this is muscle. You can train it like anything else. Below 60, you got to start getting concerned. Because things are not moving, which means you're not pushing blood around the body like you should. Yeah, that's kind of cool because he was like doing this number, and you know that's kind of cool because we all like to sometimes do that, right? Make sure we're still alive. We kind of do this, or we kind of maybe do this. Okay. Are there any other pulse points? Yes, there are 9 throughout the body. Difference is you're going to learn as you go through your programs that there is a different count based upon where you're checking for the pulse. Because you can actually check for the pulse in the feet. Okay, just make sure you note that. So, we're not going to conduct the electricity, but it's going to allow for helping that impulse travel. And that becomes important. All right? So this insulation is going to play a part in how that impulse gets to travel to the parts of the heart to make the heart beat. Now, I put this one up here because I think the textbook or lab or something, identifies it. But y'all know me. Anytime it says may, that's not a true fact for me. And I don't know if you guys know, but if you're just trying to say, well, maybe, possibly, whatever, you can't back it up with facts. All right? But they're testing this, and they think it could help in refilling the heart with blood due to the elastic recoil. So if we begin to think about our structure, it is a beautiful organ. You look at this, And we have an anterior view, note pointing to the left for the apex. The posterior view pointing to the right because we flipped it. All right? Looking at the structure, the area for our ventricles looks like it takes up most of the structure. Okay? Now, atria, yeah, until you actually get to cut one, all right, and begin to dissect it down, it's a little more difficult because it kind of looks like, where is it? All right? But the atria are not as, their structure is very different from our ventricles because so far as atria are concerned, the only thing that happens there, this is where blood returns. It simply fills. These, the ventricles, have to be muscular because they twist and push the blood. All right? Anterior, these are, I think, in your syllabus as to the parts that you have to identify on a heart. So if you look at our models that we have, models along the back, because some of them are torsos, okay? These are parts that you're going to have to know. Now, as a whole, okay, left ventricle, right ventricle, left of the heart, right of the heart, vena cava, vessels, which we'll talk about, my aorta, the aortic arch, I've got my pulmonary veins, I've got my pulmonary arteries, that little flap-looking thing is called an auricle. Now, a couple of things to definitely note on this structure. We have something called the coronary sulcus. Do you remember what that term means?
It's like the bridge that goes across in the brain.
Do what, Marlisha? And a depression, a little groove. All right? So I've got like this little groove that's termed the coronary sulcus. That's going to come back to us. Okay? I have an, now take your terms apart. Anterior on the front, enter between ventricles. So between the ventricles, sulcus on the anterior side. Does everybody see how I took that term apart? Okay. If I begin to look at the posterior side, once again, ventricles, put that phone up. The coronary sulcus continues on the posterior side. This is going to become important. All right. I have on the posterior side, enter between ventricles, sulcus. So I've got one posterior and anterior posterior. Y'all should have corrected me on that. Okay. Once again, they're given the view from the posterior side of my great vessels, where I'm going to have it move to the lungs and return to the heart. Okay. All of this you need to be familiar with. So begin to learn that anatomy. 4. Everybody say it with me. How many chambers does the heart have as a human?
4.
4. Yes. Okay. The 2 upper chambers, atria. The 2 lower, ventricles. Atria, like I just mentioned before, receive blood. They have this flap, that little thing right there, okay? They have the